In this podcast, I'm going to be talking about the nutrients in lentic ecosystems. The first words we need to discuss are the things that signify the level of nutrients in a lake, which is called the trophic status of a lake. And there are three different levels that scientists use to describe how many nutrients are in lakes. The top level is called eutrophic, meaning high nutrients, which leads to high plant growth. The second level is called oligotrophic, which is low in nutrients and plant growth. And then between the two of those is mesotrophic, which is the intermediate in nutrients and plant growth. We're talking about nutrients here. The main nutrients that determine whether or not plants are going to grow in a lake are nitrogen and phosphorus, but there are some other smaller nutrients and minerals that are important as well. So the question should be then, what types of factors affect the trophic status of a lake? What determines whether a lake is going to be eutrophic, mesotrophic, or oligotrophic, or how many nutrients are in that lake? And there are three main categories we're going to be looking at. The first is, how fast do nutrients get into that lake? And there are different ways the nutrients can be released into the lake. First of all, the bedrock of the watershed, so the land that surrounds the lake, that drains into the lake, the type of bedrock it has is going to affect the nutrients, whether it's a limestone bedrock or a granite bedrock. The types of soils in the area, so the kind of soil it is, what kind of nutrients are in those types of soils, whether the soils are easily eroded, are going to determine the types of nutrients in there. The plants growing on the soil are going to determine the nutrients. Some plants use a lot of nitrogen, some release nitrogen. That's going to affect what gets into the waterway. And then finally, how we use the land in the watershed. We've talked about this a lot already. The types of fertilizer, for example, we put on the land. If we allow wetlands to continue in that area, or if we tile out an area, is going to affect how many nutrients get into the waterway. The second big category for something that can affect the nutrient supply is the shape of the lake, which is called the morphometry. So different things in the lake can determine, how many nutrients there are. The depth of the lake, so the maximum depth, and also the average depth or the mean depth can determine the amount of nutrients in a lake. Volume and surface area, so how much water is actually in there and how big the lake is in terms of surface area, how many acres it covers. And then the ratio of the lake surface to the watershed area. Obviously, if there's a lot of land that's draining water into the lake, that's going to have different amounts of nutrients than a lake that just has a little watershed. And the last big area that affects the amount of nutrients in a lake is the climate. And of course, climate can be controlled by the amount of sunlight, can be controlled by the temperature, and also the hydrology, which in our case is the precipitation falling into that lake, as well as something called the turnover time for the lake basin, which we'll talk more about in just a moment. But first, let's look at those other ones. So amount of sunlight. Obviously, sunlight is going to affect how much photosynthesis is going on in the lake, and therefore how many nutrients are used, and then the basis of the food chain. Temperature of the lake. Most organisms like to have a particular temperature, usually on the warm side, but some organisms prefer cooler temperature, like fish that need to spawn at a certain temperature. So that can affect the amount of nutrients in the lake as well. Okay, so now we're going to talk a little bit more about this turnover time that happens in lake basins and why it happens and how it affects the nutrients in lakes. So what we see in lakes is that during different seasons of the year, there are different layers of water based on their temperature. And the reason that water will stratify or turn into different layers is because of the density changes in those layers of different temperatures. Water is unusual in that it is most dense at 4 degrees Celsius. You can see that I've had that written down there at the bottom. Okay, so this is kind of strange, that we have our most dense water at 4 degrees Celsius. So if water gets colder than 4 degrees Celsius, it's going to be less dense. In other words, it will float above that 4 degrees Celsius mark. And also, if it gets warmer than 4 degrees Celsius, it will float above that layer. So keep that in mind as we go through all of these slides, that the water that's at 4 degrees Celsius will always be near the bottom of the lake because that is where it's most dense. So pretty cold, but not frozen. Okay, frozen is 0. All right, so let's look at what happens in the winter. So in the winter, the bottom of the lake is the warmest, which makes sense because it's the least exposed to the air. So down here at the bottom of the lake, let's see, you can see we've got 4 degrees Celsius as our warmest temperature, but remember that's the most dense, so that makes sense that that stays down at the bottom of the lake. As we move up the layers of the lake, it gets colder until we get to the top where it's actually frozen and the ice layer. So 0 degrees Celsius water as well as ice is going to float on top of 4 degrees Celsius water, and that's why we get those layers of that stratification. And then in the spring, things start to change. So in the spring, we get that ice layer melting. Obviously, the sun's rays are stronger. Okay, it gets a little warmer outside. As that ice layer melts, it's also warming, as I said, that's why it's melting, and it starts to sink because it's becoming more dense, right? It's approaching that 4 degrees Celsius temperature. So going from the temperature of ice or frozen to 4 degrees Celsius makes it more dense, so it starts to sink. And then the stuff that's on the bottom is eventually going to be a little bit less dense, and it starts to rise up. So we get what's called a turnover, a cycling of the materials that are on the bottom of the lake coming upward, and the top layer of the lake sinking downward. And that brings all these nutrients that are sitting down at the bottom of the lake that have built up over the winter from things decomposing down to the bottom of the lake up toward the top. But it also brings nutrients like oxygen, for example, down to the bottom of the lake. Okay? The nutrients that come up might be your nitrogen or carbon. So this turnover creates a complete mixing of the lake in the spring, which is really important. It's a good thing to be able to redistribute all these nutrients to the different parts of the lake. Now we're going to go to summer. In summer, we start to see stratification again. So in the summer, the top layer of your lake heats up. Okay, so we get this warm layer up on top. We call that the epilimnion, kind of like your epidermis is the outside of your skin or the upper layer of your skin. The epilimnion is that upper layer of warm water in the summer. Down at the bottom, it's cooler because it's not as exposed to the air and the sunlight. Call that the hypolimnion. And then between the two of them, the metalimnion, is what we call the thermocline. Okay, and the thermocline is this transition between the cool bottom layers and the upper warm layers. So as you go up the thermocline, the temperature of the water is getting warmer. But there's a change, a definite change between the cool and the warm throughout the thermocline. So again, we get stratification once again in the summer, and those nutrients start dividing within those layers as well. This is just another example of thinking about the layers of the lake, so I wanted to show you that. Hypolimnion is down here at the bottom. Okay, see this hypolimnion, and that's where it's the coolest. Okay, the most dense, right, is at 4 degrees Celsius. And as we go up the layers, the temperature gets warmer. You see this upper layer is at about 30 degrees Celsius. Okay, that's the epilimnion. Right here in the thermocline, from here to here, you can see how much that temperature is changing. Right, it goes from about 10 degrees Celsius to about 30 degrees Celsius in the thermocline. So that's also called the metalimnion. And that's where we're going to see that greatest temperature change. Pretty much 4 degrees throughout the whole hypolimnion, pretty much 30 degrees through the whole epilimnion. But in the metalimnion or the thermocline, it's where we see that transition from the cool layer to the warm layer. All right, so I want you to imagine that this area right here, okay, is your thermocline. In the early summer, just the very top of the water is warm, so that thermocline is pretty high up. But as summer progresses, the warm water gets deeper and deeper because further and further down that sun is penetrating, that heat is penetrating. And so the thermocline sinks as we get into early fall. Okay, so where once our upper epilimnion was just a small amount, right, in the early summer. It gets deeper and deeper as we progress through the summer. So the epilimnion gets bigger, the hypolimnion gets smaller, and the thermocline decreases. You write a note of that for yourself. The epilimnion, smaller, again, as we go from early summer to late fall. The hypolimnion, back up, misspoke. The epilimnion gets bigger. The hypolimnion gets smaller. And the thermocline sinks. Again, all of this as we go from early summer to early fall.